So sometimes you'll be asked to find the square root of a number that is not a perfect square. If it were a perfect square like 9, finding the square root of that is pretty easy. 3 times 3 is 9, so the square root of 9 is 3. Unfortunately, sometimes they'll give you a number to find the square root of that is not a perfect square. So today, that is what we're going to cover. So how do I find the square root of a non-perfect square number is what that should say. So let me go ahead and fix that. So how do I find the square root of a non-perfect square number? Well, let's go ahead and think of a non-perfect square number. And we're going to choose one that's fairly easy. We're going to choose 10. So they ask you to find the square root of 10. Now, the best way to do this is write the perfect squares on either side of the problem. So if this is our problem, the square root of 10, we know the square root just under 10, perfect square just under 10 is 9, and the perfect square bigger than 10 is 16. Now, we know the square roots of both of these numbers. We know the square root of 9 is 3, and we know the square root of 16 is 4. And because the square root of 10 is between the square root of 9 and the square root of 16, we know that the square root of 10 has to fall between these two numbers. Now, I like to look at this number and I say, okay, which number is this closer to? Is the square root of 10 closer to the square root of 9, or is it closer to the square root of 16? Most of us can tell that the square root of 10 is much closer to the square root of 3. Therefore, it's not going to be directly in the center. It's not going to be 3.5, which would put it right in the middle. It's going to be much closer to the square root of 9, so it's going to be much closer to 3. So oftentimes, if a number is closer to the lower, I say to go ahead and put a 0.2 near it. If it's really close, you could put a 0.1. If it's directly in the center, you could put a 0.5, so 3.5, that this is not directly in the center. And if it's closer to the 16, let's say it was the square root of 14 or the square root of 15, then I would approximate it as a 0.8. Now we can see that it is closer to the square root of 9, so we're going to go 3.2. So we're going to go 3.2. Okay, and this is an approximation, so you put the little approximation symbol. Let's do another one. Let's find the square root of 140. Now, once again, we're going to find the perfect squares on either side of 140. So we have 121 and we have 144. The square root of 121 is 11, and the square root of 144 is 12. So we know that the square root of 140 is between these two numbers, which means it's between these two numbers, because remember, these are equal and these are equal. So square root of 140 has to fall somewhere in between there. Now, if it were directly in the center, we could say, okay, it's probably close to 11.5, but this is not directly in between 121 and 144. It's closer to the 144. So I'm going to say that this is closer to 11.8. Once again, we're approximating, so we have to put the approximation symbol. Let's do one last one. Try to find the square root of 295. Go ahead and pause the video, try to figure this one out on your own, and then come back when you are done. Okay. Welcome back. Hopefully you realized that the square root of 295 is between the perfect square roots of 289 and the square root of 324. So the square root of 289 is 17, and the square root of 324 is 18. Once again, we know that 295 is much, much closer to 289. And so hopefully you came up with something close to 17.2. Now it's very close to 17.1. So if you approximated 17.1, that would work as well. If you approximated 17.3, you're getting a little further away, but I don't think I would take off points for that one.